Hey everybody, today we will do another video, and today we will do something that is very good, very cool actually. We will learn how to read the distance, right? Using an ultrasonic sensor, an Arduino microcontroller, and an LCD. The LCD stands for liquid crystal display, right? So yeah, I want to make that clear because I don't want anybody to think that I'm using the least common denominator to do this stuff, right? Of course, I guess part of it, right? We will have some little bit of mathematics, but not going to be that complicated, right? Okay, so let's say that that we have some object, right? This object here, right? And then you have the ultrasonic sensor, right? The ultrasonic sensor has two like a little lenses, right? And one is receiving the frequency from the object, right? And the other one is like a bouncing out the same frequency. So it's like a receiving and transmitting type of thing, right? Based on that, you will kind of read the distance, right? So, and let's say for this specific example, let's say that to make things a little simpler, you can actually use any number. In this case, we're using 10 centimeters, right? The distance between the object and the sensor, right? And then, so let's say that we use this number just to do basic calculation, to have a number to write the program, right, on the Arduino IDE. Okay, so what we do is we put this distance right here, and we assume that this is 10 centimeters away, right? Then we come over here and we said, okay, what is the speed of sound? Well, the speed of sound is basically approximately 340 meters per second, right? Then we said, okay, so, but to have the measurements in seconds, remember, computers and microcontrollers, the more accurate you go on the reading, the better results sometimes we get, right? So in that case, with that being said, what we can do is change the unit, right? Reduce the unit, right? And how we do that, right? So we said that we actually well, we do it the following. So we actually multiply, right? There are how many centimeters in a meter? 1 meter is equal to 100 centimeters, right? And we want to change that unit to centimeters because that was the unit that we based on the distance between the object and the sensor. Then we cancel meters, right? And we got centimeters, right? Multiplying that is equal to 34,000 centimeters, right? Then, so in this case, what do we do, right? What do we do? We know that in order to be more accurate with the Arduino microcontroller, we can actually use the microsecond delay, right? So with that being said, we got this number, right? We change the rate from this amount of centimeters, right? So from this amount of centimeters, right? So what we do is the following. So let me explain this. So what we do is we say that was meters per second, right, initially, and then we come over here, we divide the meters per second, right? 1 second divided by 1 times 10 to the minus 6, which are microseconds. Then we come over here, and that number is a big number. Is this, right? Then we cancel the zeros, right, to reduce the numbers, and then we got a 34 over 1,000, right? Then, after we cancel the zeros top and bottom, right, we got 34 over 1,000. We divide 34 over 1,000, which is equal to what? It's equal to 0.034 centimeters per microseconds. That little symbol is called the mute, right? Now we come over here and we do the math, right? We continue and we got this number, right? So now we got the number that is basically the velocity is that, right? Now, how do we find the distance? Well, distance is equal to 10 centimeters, right? Then we come over here and let's say that you want to find actually the distance equal to this, right? So then what you do is replace 10 centimeters, right? Replace D with 10 centimeters, and then you solve this, right? So of course centimeters over here will cancel out, and you will have a number, right? And then you will have that number right there, right? So here you divide by that number and then to solve for T. Now you know that T is 294 microseconds, right? So we have a value for T, right? Now we can use this information to write our program, right? Now let me just show you the little quick the hardware, because I draw something because it's going to be hard for me. I don't have a high-speed camera with, you know, like a studio, right, to be able to see all this stuff, right? No, obviously I don't have that. So what I did, I draw, because I cannot really show you all the wiring, right? I draw using a program that is called FreakScene, right? And with that, now that we have that, we can go to our schematics, right here, right? So this is a free software. Actually, right now it's not free, actually. I guess you have to pay for, but I was able to get this free, right? If I am doing tutorials for free, right, I might as well trying to use some free software, right? I guess that makes sense, right? Now, this is what happened here. So here, as you can see, we got the sensor, we got the liquid crystal display LCD, right? Then we have the Arduino microcontroller, and I use the Arduino Uno. I don't know if the Mega is available in this. I don't think the Mega is even available in this software, right? But what I did is the following. So what I did is that I need 3 devices, right? And devices have to be, they gotta be hooked up to power in order to work, right? Okay. So the Arduino is supplying 5 volt to this breadboard, right? Then it's activating all this channel here all the way through. This is hot. This is a hot rail right here, right? Then we have the ground rail. Well, we have a hat coming out of the red, and then we have a green going to the blue, right? So this road, this is ground, this is considered hot, right? Now, the sensor right here, this is the ground, this is the pin at the ground, I go to that pin right there, this, and then this is the hot, this is, which is the positive, this is the negative, to be more clear, right? I am talking in general purposes. When I mean hot, I mean positive, right? So this is the 5 volts going over there, right? Positive 5 volt going to PCC, right? Then we have the ground going to the ground, and then we have the trigger pin coming over here going to number 11, right? This is the trigger pin. The echo pin with this yellow one is coming over here, and it's going to number 10, pin number 10 in the digital side of the Arduino microcontroller. Next, because next is the same thing for 4 pins, right? One from here going to the hot, right? Rail, and this is going to ground. This is a positive from the LCD to the source, right? This is positive, this is a negative. Next, we got 2 wires, right, coming off to the LCD. One of them is called the data. This yellow one is called the data. This one, this kind of brownish color, this is the clock, right? So, with that being said, that's why I wrote data and clock, right? With that being said, we have already the schematics, right? Okay, so now let's jump into the code. Okay, so the code for the Arduino is right here. It's the following. The Arduino microcontroller take the library, right? So it's similar to C and C++. As a matter of fact, this IDE was developed on C and C++. The only thing is that this is more like a real deal thing that work with the GPIO pins of the Arduino, right? Of course, you can do simple functions over here, do simple programming, but this is more like for like embedded system type of project, right? So we have the liquid include. We include the liquid crystal library with the I2C square, and this is the header file. You can go and Google I2C square, and you will find this library, and you can include it in your code, right? I did not write this library. If I have the tools available in there, why should be writing the library, right? So I did not do that. Then we include software serial, right? We include the software serial.h. This is part of the Arduino, right? And that is another header file. Then we come over here, we declare some variables we call custom int for the echo pin of the sensor that I just showed you, right? In the schematic. constant int echo pin equal 10, constant int trigger pin equal number 11, pin and number 11, like I show you. Then we declare a distance int, right? Because it's going to be only 100 centimeters, right? I don't have a lot of room in this room, so this goes up to 4 meters. It's able to read from 4 meters down to 3 centimeters, right? But in this case, I am just doing 1 meter, so I am declaring that just basically int. And then we have the long. The long is going to be we declare long because the duration is going to be probably a lot of microseconds. So we need a bigger number, right? A bigger type of data type, right? Now, so right here we come here and we include the liquid crystal library LCD, right? And then we come over here and the boil loop is already in the Arduino IDE. You don't have to write this up, it's already there. All you gotta do is set up the P mode. The boil loop is like a code when you're writing a function prototype and see that you have a function prototype above the main. Does that make any sense, right? On C++, you write a function prototype above the main. The same thing with this void setup. This is a void setup, right? So here in this void setup is doing the same thing, right? Over here we just set up the pins, whatever we're going to use, right? And then so the P mode, right? So the brackets are already there for the function, and we said P mode echo pin input, right? You will be receiving the signal from the object, right? The echo pin. Then we said P mode trigger pin output. It will be outputting the data. Then the serial begin. If you want to display this data in the serial, so this is a baud. It's called a baud rate, right? Baud rate, right? Now, right here, we actually declare the LCD.init is a function from the LCD. LCD begin dot, right? LCD.begin and 16 and the 2. Those are 16 columns and to row in the LCD, which I am going to show you very soon. Okay, so then we actually turn on the light, right? It says light LCD backup light, right? LCD backlight, sorry. So then we come to the boil loop. This is where the action is happening. This is built into the, and when you upload this into the Arduino, obviously it will be running. So basically we're running, right? Of course you can modify the code not to do anything, but it is built into the software. You cannot basically remove this function, right? So when you do this, then you're over here, you declare LCD clear, right? Then you say when LCD clear, right, that will clear the LCD. Now digital write, right? Digital write mean writing to the trigger pin. Low, right? Delay 2 microseconds. Digital write trigger pin height. Then we actually go in delayed microseconds from delay for 10 microseconds again, right? I'm wondering, it's kind of going light and low, right? I'm sorry, what did I say? High and low, right? Somebody said, oh, when they go low, we go high, right? Interesting. Okay, never mind. Okay, so this is what happened. So and I think the same person said he had no hope, right? I guess there was no more hope after being out of the White House. There's no more hope, right? But we have a road over here in Tennessee. It's called a New Hope. Actually, it's not only a hope, but it's a new hope. It's right here, just on 24, right? But anyway, so what we do here, right? So then we have the digital pin triggered low, right? Right? Then we have this here, right? See the one that we declared, we call duration. That means time. The T that we just found in the little mathematics that we did, right? So the duration of this is going to be equal to the pulse end function, right? And the pulse end function will take the argument of the echo pin and will turn that high, right? Which is the input, right? It will read, right? The input, right? Then we come to the bottom, right? We come to the next line, sorry, and we say the distance divided by 2. Why? Because it takes to get the total distance. We got signal coming in from the object to the sensor, and then it's bouncing back to the object. That's why we divide it by 2, right? So I told you we're going to have I was going to have a denominator here, but technically we have a decimal divided by 2, right? So okay, anyway, but it's not an LCD. It's not the lowest common denominator now. Okay, so now we actually do the distance. Put an if statement. If the distance is greater than 100 meters, oh my god, 100 meters, no, it's 100 centimeters. Remember I told you I don't have a long, this only up to 4 meters, but I don't have that much room here. Okay, so we do, if the distance is greater or equal to 100 centimeters, then LCD, right? Then set up the cursor at 0, right? 0 in the first is equal to 0. The first the first little, I guess the little place, right there. Okay, then I was doing this in Spanish, but I was having an issue with the camera. That's why I didn't, upload this video, because I was having problem. The camera that I have is not the best, so it was not. I had to put it like this close, to the LCD in order to read, in order to see what is it, the printing in the LCD. So yeah, so very pretty much. But anyway, so then we do this, right? So then we actually print the distance, right? In the LCD. So we do LCD print distance, right? Remember a few days ago, I actually did a video on the structures that take the dot operator. Well, this is kind of similar. Okay, so then the LCD print distance, right there, then the LCD print, and then distance, right? The distance is, right? And then some of this stuff is, I think I wrote it with the purpose of seeing that in the monitor, right? I don't know if I will do that, but if you know, just for debugging purposes. So, but anyway, so right here you can see, right? And then print centimeters, right? And then LCD, set cursor to 1 to 2, right? Right? Then delay, right? So let's do that. All right, now else, if this is not the case, and remember when we don't put this, we just put the delay function, that will be considered in milliseconds, right? If we don't specify, it's microseconds, right? And I said else is out of range. In other words, if it doesn't sense anything within a meter, it will not do anything. It will say out of range, right? So let me just load this into the Arduino, and it's loaded, right? And I'm going to show right now how this stuff is looking up. So right here, as you can see right now, right? Right now I am, you can see, let me just do it with this piece of paper. So this right here, these are the little things in the sensor, right? So one of them is receiving the signal, and the other one is just kind of transmitting, it's bouncing back, right? So in this case, well, apparently this is kind of emitting a frequency of 40,000 hertz, right? Okay, so let's do it with a piece of paper, right? So look at that right now, right? So it's reading 8 centimeters. I go closer. 3 centimeters right there. 4 centimeters. Closer. It's pretty close. It's still reading 3 centimeters, but again, this is not like, you know, I think it's a plus or minus 3 centimeters with plus or minus 3 centimeters of error, right? But right here, if I step away and I don't have anything now, it will say out of range, right? It's not sensing anything. But if I do here, if I come close to a meter, see that's 84 right there. 84 centimeters, I am going far away, I am going far away, I am going far away, and it's farther away, and probably, okay, I think it's sensing me, it's not even sensing the paper, but we'll see. So here you go. You see that 100 right there? Our range. We coming closer. Well, it is because the distance of this, well, the thing is, this is the direction, right? So it's right there, right? So that's 20 centimeters. I'm getting far away, out of range, right? Right? Then we getting closer. Okay, getting farther, right? 87. See? Then we're getting closer. Getting closer. See that? It's kind of hard to do it because to kind of identify where the direction of this is. But you can see right here, right? You can see my piece of paper where I have it. If I am getting closer to the sensor, that this is getting shorter, but at the same time, you go. So it's lower. You go. It's lower. That's why. See? See? Out of range. Now I'm getting closer. 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 I am getting closer. I'm getting closer. And it's getting closer, right? See that, right? Alright? So, okay, so now this is what happened here. So, okay, as you can see that I have the breadboard, I have this, right? I have the sensor, and then I have the LCD where you actually see it right here. That's the LCD, right? Then I have the Arduino microcontroller. So let me see, right there, right? And that's why I told you guys that I cannot show this to you too much because the camera system that I have is not the best, right? That's why I did a little diagram over there. So I hope you guys enjoyed this video. If you do, please give me a like, right? And remember that we learn a little bit every day because Jesus is good with us, right? Thank you for watching. Right, bye-bye.